I wanted to begin this lesson with a little story that takes place here at the California State Fair. All right, so seriously, this is a really important lesson today because it's the whole reason that I became a veterinarian. Okay, maybe it's not that important in the grand scheme of things, but it's important to me. And it all happened here at the State Fair. And I'll tell you more about that a little bit later. So let's begin today as we learn about the digestive system. Oh, that's a great picture. All right. And I found my passion at the State Fair. And speaking of passions, that's a good introduction to your capstone project. I emailed you about this a few days ago, but I just wanted to talk to you a little about it. This summer, start thinking about things that you're excited about, things you love to talk about, things that maybe that annoy you, that you'd like to do something about. And I'm sorry, that's weird. Because in your second year, you have time to start working on what's called a capstone project. Now, capstone refers to kind of the culmination of everything that you've learned so far, that you've learned in the classroom, that you've learned at your internship sites, you've learned at work, that you've just learned throughout your life. It's not. I'm making it sound like it's some like a PhD, and it's not. It's not that big, but it is something that I think you'll find enjoyable and um, um, and is a chance for you to really share something that's important to you. And by the way, it's something you can talk about with employers. It's quite a few graduates have talked about their capstone project, and that has sort of set them apart from others, from other veterinary technician schools. So there's a practical side to this as well. I don't have any pictures from last year's class, but this is from 2 years ago. This is Shayla Choate, and she talked about large animal therapy for kids with special needs. Taylor talked about behavior changes in shelter dogs. Tiana talked about disaster medicine. Um, oh my gosh, I can't believe I'm forgetting people's names. Oh, I'm so embarrassed. Um, oh, she would just hate me. Well, anyway, um, she talked about beta fish. Ivory talked about, I'm just, let's not even, let's forget I even, I'll never forget your name. All right, that's, um, okay, hold on. This is gonna drive me crazy. Okay, Eliza. That's Eliza. Okay, there's Ivory talking about sedation. Laura's talking about, she really got annoyed at people who would call their dogs wolf hybrids. And so she kind of wanted to debunk the myth of the wolf hybrid. Carlos talked about specific laws that um, are biased against pit bulls. Ariel talked about, it was an interesting look at how kind of the lack of communication or databases, I should say. Um, there was no easy way for zoos and aquariums to share medical records. And Jen Moore spent part of the semester traveling with one of the last kind of mobile vets up in the foothills. Katrina talked about leptospirosis, and it was all really interesting. So those are all things they really cared about. And we all learned from each other. It's very exciting. Members of our advisory board come, other faculty members come, our dean and our director of CTE have come. So it's exciting. It's a chance for you to talk about something you've learned about. Anyway, and today, digestion is something that I care a lot about. And I just thought we'd just begin. Here's a peaceful scene, right? There's a horse, just kind of, there's no subtitles. I'll provide the subtitles. Munch, munch. Okay, but just think about what he's doing. He's eating something that you and I cannot eat, right? This is a gigantic, powerful horse, and he's eating this grass and flowers and weeds. If we ate them, it would just pass right through us. So how is he able to eat them and we're not? That'll be one question that we'll answer. And not just horses, but this guy, right? Here's a cow. And not just with the cow, notice the cow is doing something a little different from the horse, right? The cow is chewing his cud. Horses don't chew their cud. So there's something similar about cows and horses, but there's something different too, right? And you'll learn more about those differences today in veterinary physiology. So many different digestive systems. They all have certain things in common, right? They all have, a mouth and an esophagus and a liver and, this tube. And I like how the book describes this. It's a little hard to imagine, but you have this tube running through you. It would be a little easier to imagine this if you were just a worm, right? If you were some worm and you just had some little tube running through you. But the book compares you to a donut with a hole. And the hole is not inside the donut, it's this hole. Well, you have a hole too. Your whole digestive tract is this hole that runs through you. As the book said, it has a few more twists and turns than other holes, but still it's a hole. And the reason I mention this is because diseases of the gastrointestinal tract can be kind of hard to diagnose. We've got great blood tests, but they're not great for the digestive tract. They're great for the liver and the kidney and things like that, but the digestive tract is outside the body. And that's why in people and in animals, sometimes we have to do biopsies or endoscopy or things like that, where we actually go in with a camera and take a little piece to diagnose certain gastrointestinal diseases. But just think about it, this crazy little tube that runs through you, and how these four species are a little bit different, right? We got these two herbivores, and we have this carnivore and this omnivore, all a little bit different. And this is what we're going to go over. I know this looks kind of busy, but we're just going to go over all the different parts, how this all comes together to provide you the nutrients you need and to help you get rid of things you don't need. And so you can always kind of, if you want, you can refer back to, you could just look at this and you're done. See you later. So we'll refer back to that. But our objectives is we want to list the functions of the digestive system, describe the different epithelial and muscle layers of the gastrointestinal tract, explain what you're seeing here, this kind of weird churning, moving that we call peristalsis and segmentation, as well as this kind of interesting feature of your gut called the enteric nervous system, which helps control all this. We'll learn about the types of tooth found in carnivores and herbivores, and some of the structures of the monogastric stomach, and describe the function of each area. We'll explain the effects of various digestive enzymes and hormones and ions. We'll describe the structure of the foregut, and by that we mean like the cow. So the rumen, the reticulum, the omasum, the abomasum. That's me right there, a very young me doing surgery on a cow. We'll also talk about horses and the structure of what's called hindgut digestion. And then we're going to compare and contrast cows and horses using them as models. Um, the little quiz thingy, I will get that up on Canvas, so you can look at that and check your own answers. And there will be some student notes up there too, so you can. When I send out the email, when these are up on Canvas, then you can. I'll mention that. So you should already know that. Anyway, and of course, why are we here? Because you're here to help animals with all these crazy problems. Everything from this weird cat disease called the resorptive lesion. Here's a dog that's his big old carnasial tooth, and there's a big old slab fracture. Ouch. Some dogs and cats will have what's called a retained tooth. The baby tooth is stuck in there with the adult tooth. Horses are not, they're not immune from dental problems. This is a veterinarian who's about to work on a horse. He's just flushing all the food out of the horse's mouth. And you're gonna see, he's gonna go in there to try to look at a horse who's broken off the top of one of his crowns. And there's a bunch of food on that tooth. So I think he's gonna get it off. It's kind of weird looking, like those are horse teeth. Go look at your own teeth. Horse teeth are really different. He's just getting the food out, getting these weird, kind of weird, flat, ridged teeth. We'll learn more about horse teeth in a little bit. We'll learn a little bit about gastric ulcers. That's where the stomach is kind of digesting itself, digesting through its wall. We'll learn a little bit about parvo, a really horrible disease. We'll talk just a little about colic. Hopefully some of you are going to discuss that this week. Colic is a general term. It just really just means abdominal pain, and there's lots of different kinds of colic in horses. Some are medical, they're treated medically, some require surgery. You'll see later some reasons why horses are prone to colic. Sometimes they just have an impaction, a bunch of dry feed in their colon. That's probably one of the most common reasons. Sometimes, horses are so big. I was talking to Raina and Nadine and Emily about this. Horses, they have so much weight in their intestines that things can sometimes roll. Anyway, watch this. You're just going to see part of this is a horse, and then we're looking here at his colon, and it's just twisting around. And then, of course, the whole thing's going to fill up with all this trapped gas, and then it's going to turn kind of an ugly purple color. So that horse needs surgery. Cows have their own kind of unusual problems. The rumen is a really amazing part of the digestive system, but it's also, if a cow eats too much grain, they can change the pH of the rumen, which can have all sorts of problems, kind of showering the body with bacteria, causing not so, I wouldn't say it was going to, well, yeah, it can cause polio, that's true, for different reasons. So these are all these different diseases that can be caused by rumen acidosis. Some cows burp. They burp a lot. And if for some reason they can't burp, they have all this gas they're producing, and they'll just swell up and bloat. And here a veterinarian is using what's called a trocar. It's got a little hole in the middle, and she just punched that through the skin into the rumen, and then she's going to pull a cannula out, or is that what it's called? Anyway, now you can't see it, but gas is rushing out to deflate this cow. We see problems where the pancreas, it's not, it's outside the digestive system, but it's an important part of the digestive system. It can develop problems. There's a variety of liver problems. We're not going to talk about them this semester, but shunts we've talked a little bit about in the past, and we'll talk more about them in the future, as well as other liver problems down to the colon. You know, with the cats in particular can get this problem where their colon gets all stretched out and they get this horrible constipation. And then there's the things that are just plain old normal, like rabbits. And why do they eat their poop? Okay, technically, they're not eating their poop. They're eating these things called cecotropes. But it's normal, and you'll learn why they do it. And today is just a taste of what we could, it's a little pun, a little physiology pun there. It's just a taste of everything you could be learning. And you're going to see the digestive system show up when we talk about medical nursing and surgical nursing and things like that. Maybe some of your case studies are on a digestive disorder, this week's discussion. And you may find you really love the digestive system and you could go to work in internal medicine. So just keep an open mind. Well, let's start by just looking at the basic structure here. So there are 4 layers to the stomach, the small intestine, the large intestine, all the same. These 4 layers. One's called the innermost layer is called the mucosa, and that's where all the epithelial tissue is. In the mouth, it's stratified squamous, and we'll review that. As you move down to the esophagus and the stomach, and it becomes what's called columnar, but we'll describe that again. A lot of glands in this part of the, well, no, I'm sorry, that's just kind of that's that first layer. The next layer, the submucosa, that's where all the glands are. We've got blood, lymphatic vessels are found there. You got a muscular layer, right? Because the stomach and your intestines and your esophagus, all these, they all move. They move food forward, they mix up food, so they got to have smooth muscle. And then there's this layer outside called the serosa, and that's kind of a connective tissue. It's a little more tough than the other layers. And why is that important? You know, there are diseases that will affect different layers. Humans have a disease called Crohn's disease, but there are many veterinary diseases that are similar, that dogs get, cats get. Cows get a disease called Johne's disease, which is very similar. Just look how, it doesn't tell us what layer, but I think we can assume this is probably like the submucosa. Maybe the mucosa and submucosa, they're all weird and thickened here. And so you can imagine people with Crohn's disease or animals with a similar disease, they just can't digest food very well. And of course, that's the whole function of the digestive system, is to take nutrients from the outside world and you know, break down the fats and the proteins on our carbohydrates. Absorb water is another function. In some species, certain nutrients are made in the intestines. So, and all the different parts, from your lips and your tongue, your teeth, down to your anus, right? They all play a role in this intake of nutrients and getting rid of waste products. And this first part is just kind of a general overview. So there's these 2 concepts of peristalsis and segmentation. And peristalsis refers to sort of this forward movement of food. When you swallow, that's peristalsis, this particular muscular movement that's moving food down your esophagus. Segmentation is what you saw in that video. Segmentation, you'll see in a moment, is moving food backwards and forwards and mixing it and kind of, yeah, just mechanically churning it together this way and that way. And these two things are happening at the same time. You can see food moving forward, but food is also moving backwards and getting mixed together. So that's, you're seeing it all happening, and this is that muscularis layer. And there's your breakfast traveling through. Yeah. You have different kinds of epithelium in different parts of your body. You learned about how in the alveoli of your lungs, you have these very thin, simple squamous epithelium over there in, right, in your lungs. And we didn't really talk about it, but in your nephron, you actually have these little tubes here. And you learned how in your bladder, you've got these transitional epithelium. Well, what's kind of interesting in your intestines, well, let me come back to that. You have in your mouth, in the areas of the digestive system that see a lot of trauma, you have what are called stratified squamous, right? So different from simple squamous, which are flat, stratified squamous are stacked on top of each other. We learned that in the vagina, that's stratified squamous. That's another area that gets a lot of trauma. And next week, you'll see your skin has stratified squamous. So anywhere where there's a lot of, trauma, we don't want something kind of delicate like these other epithelial tissues. We want something that's got lots and lots of layers and that we can lose. If you eat a piece of hot pizza, right? Well, so you'll burn this top layer. That's okay. You're going to make more. But as we move down to the esophagus and the intestines, we get what are called simple columnar. And these are really good at secreting things and at absorbing things, and absorbing things into the bloodstream. And again, just showing you, right, he's chewing on a stick. So we want to have these layers of epithelial cells. And then in the intestines, it's kind of cool. Not only does the mucosa have these epithelial cells, but they're actually these little fingers. If you were to zoom in on, in fact, let's do it. Let's zoom in on some, oh, it's so annoying. Sorry, hold on. Let's see. Okay. So we're just going to zoom in on these intestines, and these are these big things are called villi. And if we were to zoom in on them, we would see all of these, millions of columnar epithelium. And what's really cool, if you zoomed in on the columnar epithelium, they have even smaller little projections called microvilli. And the effect of all this is it really increases the surface area of your intestines. Your intestines are not just this flat, stuff like paper. There are all these little fingers, and all the little fingers have little fingers. So if you were to take your intestines, and the total surface area is really like, I don't know, it's like a lot. I want to say a football field. It's probably not that much, but it's a lot. And that same concept we'll come back to a little bit later about the surface area. How does your intestines know to do this, right? You're not telling your intestines and your stomach to churn. Your autonomic nervous system can make things churn faster or slower. For example, the sympathetic nervous system, the fight or flight system, it tends to slow down the action of peristalsis and segmentation. On the other hand, your parasympathetic nervous system is what makes it, you'll see it makes you produce saliva, you produce stomach acid, it gets things churning. When you're feeling hungry and suddenly your stomach starts, grumbling, that's your parasympathetic nervous system. So they make things go faster or slower or be less active or more active, but they don't make it actually move. For that, we have this thing, it's called the enteric nervous system, and I've tried to find a good picture here. You have this whole, it's kind of hard to explain. It's called a plexus. And a plexus just means an intricate network of nerves. So there's no actual, brain here, but it's its own kind of separate little system. It's sometimes called the brain of the gut. And it has its own little pacemaker cells that, just like in the heart, but these are little pacemaker cells that trigger a wave of peristalsis or a wave of segmentation. And as we said, this doesn't require any input from the rest of the body, just like your heart does not require input to beat. Again, the sympathetic nervous system can make it turn and move more slowly because you don't need to digest. You need to get away from that, cow running after you. But when it's Friday night and you're binge watching a TV show, then the parasympathetic, you know what I'm saying. I'll just stop there. There is one particular nerve I think you've probably learned in anatomy, and that's the vagus nerve. And I just want to mention that because you're going to see this nerve show up when you are the anesthetist and when you're dealing with other surgical cases. It's this crazy long nerve. It means the wanderer. That's what vagus means. And it is really long. It's one of those brain stem, it's one of the cranial nerves. But look, it goes down, it innervates the trachea, it innervates the lungs, it innervates the heart, the liver, the stomach, the gallbladder. I mean, it's really a long nerve. And the reason I mention this is its main job is for parasympathetic stimulation. So it is very active on Friday night when you're binge watching whatever. And this just kind of describes some of the things it's doing. It's telling the stomach to empty its contents. It's telling the pancreas to secrete enzymes. And I just mention it because you'll see actual problems. You'll notice, let me back up, it travels through the lungs, right? Well, cows are really prone to getting pneumonia, right? All this goo and inflammation in their lungs, and that can disrupt the transmission through the vagus nerve. And cows get this thing called vagal indigestion, where the message is not really getting through in an effective way. And I don't know if you can appreciate this. This cow she's not bloated like that other cow, but her rumen is just not churning the way it's supposed to. So she's got this big old gas-filled rumen, and this is what it would look like on the side. That is not what if you're out of the farm, go look at Megan Motz's cows. They do not have this big old gassy bubble. And also they get this other little, this is the abomasum, and they call this the papal shape for pear and apple. So this is kind of the apple part, and that's the pear part. And so papal, the papal shape. Anyway, you'll see this, it's not a deadly disease, but the cow just is not going to put weight on. She's just not going to be very, very effective. She's not going to utilize nutrients very effectively. Okay, anyway, that's just kind of an overview of how the gastrointestinal system is regulated. Now let's actually look at some of the parts. And there's so much you could say a lot about lips and taste buds and all that, but we're going to just focus on a few big things. So let's start by looking at things like the teeth and the salivary glands are the main two things that we'll talk about. And just kind of appreciate, right? In these guys, their teeth are quite sharp and raised and a little bit irregular, looks almost like a little crown, whereas in the horse, they're really flat. They have these little ridges and grooves, but they're nothing like the dog and the cat. There's different types of teeth. This really applies more to the omnivores and well, I guess it kind of applies to everybody. Okay, so you got incisors, right? They can help you cut food, canines, right? Well, you can read what they do. But you'll see that with each animal, we get some slightly different numbers and slightly different appearances. So a dog and a cat, they're kind of similar, right? We've got this really huge incisor, these little premolars, and these molars, right? And like we said, this is for cutting food, shearing food. These guys are used for crushing and grinding. But compare that to a horse, where he has this huge row of premolars and molars. He has this one weird little canine. But all these premolars and molars, right? The horse is a grinding machine. You can eat food and grind it up. And same with the cow. There's this one particular tooth. Let me just go back to it. This tooth right here, it's called the upper fourth premolar. It's called the carnassial tooth. And actually the lower tooth, actually I have a better picture of that. Here it is. I got this all out of order. I'm sorry. I meant to move that other picture. So actually, I meant to move this picture. That's okay. So again, we're just talking about some, the incisors and canines and premolars and molars, and how carnivores and herbivores can look a little different. Even the herbivores can be different. So you notice that cows and sheep and goats, they have no upper incisors. They have lower incisors, but they have this really a lot of stratified squamous tissue here. It's called the dental pad. It's this really tough pad that that's all they need. They don't need to bite. They just need to grab a hold of that grass and eat it. Horses do have teeth. Again, they can use it for, even though I would think they'd be okay with a dental pad, but they have teeth. So there you go. And again, just looking at carnivore teeth and herbivore teeth, you can just appreciate the difference in appearance. And then that one particular tooth that the carnivores have, both dogs and cats, it's this upper fourth premolar and this lower first molar is just huge. It's a really huge tooth, much bigger than the other teeth. So again, really used for biting and grinding. But that tooth can also is the tooth that's probably like most likely to get abscessed. It's a big old tooth. I'll grab a little dental model in a moment and show that to you. But it goes right up underneath the eye. And so if the root gets infected, we get what's called a tooth root abscess. Any tooth can develop an abscess, but that seems to be the most common tooth. And you get this big old thing of pus. So you got to go in and remove that tooth. So let's talk about the actual teeth themselves and the different parts. Every tooth in your body has this. Every tooth in every animal is like this. It all kind of starts out, and you're going to learn more about this in dentistry. So I just kind of want to introduce you to just some concepts here. Enamel is tough. It's the toughest substance in the body. It's surrounding sort of the bone of the tooth called dentin. Dentin is also tough. It is more tough than bone. This bone of the jaw is not nearly as dense and strong as dentin, and enamel is even tougher. And teeth are alive. We don't think of them, but they have nerves and blood vessels and tissue as we get deeper in. They are living structures. There is a little ligament that helps secure the tooth into its socket, and we have to use that to our advantage when we need to get out of, when we need to extract a tooth. You'll need to fatigue that periodontal ligament to help get the tooth out. And then just these other parts, the crown, the neck, the root, very exciting. And it's all the same in other species. It just looks different. Like this is a very different looking tooth, right? But this is a horse tooth, but it has the same parts, right? We got enamel, we have dentin, I'm at the moment, I'm forgetting what exactly cementum is, but that's okay. We'll learn next year. Some animals, some species have teeth, or either all their teeth or just certain teeth that erupt continuously. Can you imagine that if your teeth just grew and grew and grew throughout your life? Um, so in some animals, like the horse, it's their incisors and all of their cheek teeth. So all of their premolars and molars, not their weird little canines. In rabbits and rodents, you've probably seen their incisors will grow and their cheek teeth too. In boars, their tusks, which are their canines, grow. Ruminants have some teeth that grow as well. So you've seen little rodents or rabbits that need to get their teeth trimmed. Again, just showing you all the teeth in a horse. When these certain parts get too long, they call them points. And you'll see, I would demonstrate if you were here, but horses' teeth don't line up very well. Hold on a second. Oops, sorry, everyone. Okay, sorry. I'm just going to go grab something. Sorry to keep you waiting. Let me grab a couple things. Okay. So this is not a real skull, and I'm not sure if the computer will let us really look at this. Sometimes if I stand in the way, so if you can look real close, you'll see. Let's see. Oh, geez, that's weird. Well, if you look real close, you'll see that the horse's upper jaw is wider than his lower jaw, and so when he's grinding his food, the outer aspect, what we call the buccal aspect, they don't grind anything, and so there's nothing to stop them from growing and growing and growing. And so you see that's why we get these points right up here. The outer part of the upper teeth grow really long, and then the inner part of the lower teeth grow really long. Put this down here. You know, we have to trim these guys' teeth. We have to sedate and trim these guys' teeth. We did that a few months ago, and hopefully you'll get to do it next year. And again, this is just showing you a horse with these little sharp points. And look, it's actually making an ulcer in his teeth. And then again, just putting his tooth there, as here you're seeing it on its side, and then right, this up here, right, that's what you're seeing up here. You can't really see it, but that's the top of his tooth there. Okay. And I thought we'd just watch a little bit of this video. This is horses actually have to have their teeth floated. What that means is we go in with a special power tool with a kind of a diamond burr that smooths down those points, and they do a pretty good job demonstrating it. I'm going to skip over the first part, and this gentleman here is going to demonstrate.
Welcome to Vet Ranch. I'm Dr. Matt, and with me I have a new veterinarian on the channel. This is Dr. Dave. I've known him since we were both in vet school together.
And they've rescued this horse, but the horse keeps choking on food, I think, and dropping her food, what's called quitting, I think. I'm not sure how to say it. Quidding. And she's really kind of skinny, so they want to get some weight on her, and they realize part of her problem, you can see she's choking.
really common, especially in older horses. And once we get her sedated, we can show you. But what we're going to do today is float them, which is a really common procedure in horses. Where we grind these sharp points off and level them out so they're flat and smooth, and Flower will be able to eat a little bit better.
So what's the plan with Flower? She's at a rescue right now.
She's at a rescue right now. We're going to get her all fixed up and hopefully get her adopted out sometime soon.
And it's pretty hard to find homes a lot of times for older horses. No one really wants them anymore. So that's where rescues are good, because they step in and they fix whatever issues they have and try to place them, because that's not a very easy thing to do.
Right. It's a lot harder to adopt a 1,000-pound horse than it is a 20-pound dog. So
right.
That's our goal. Okay, so this is just basically horse mouthwash. It's a little bit of antiseptic and some warm water. She's getting good and sleepy right now. Before we put all the crazy gear on her, we're gonna wash her mouth out, make sure we get all the hay and feed out. We'll do each side. So you can see Flower's got some pretty sharp edges here that are cutting on her tongue. She's got similar type ones up here, up top, that are cutting on her cheek. And you can see she's impacting some feed up in those molars. And we can look at the other side. And it's pretty much the same. Big, sharp edges there. And so I'm pretty sure that's why she's been choking. Is her mouth hurts. So what we're going to do is grind those off.
And they also use their teeth to grind up their food, so that when they have all those sharp points, they're not going to be getting adequate grinding in. So making two flat surfaces will make it to where she can digest food a whole lot better, right?
Exactly right. And a horse's teeth grow continuously for most of their life, and so as she chews, they wear in different spots. And so that's why we see one side growing higher and on the top and on the bottom, because she's actually grinding her own teeth down, but at her age, she needs a little help to grind those sharp points down.
So I'm going to pause it there. I just wish you were here. I could show you the tool. Normally we go out and we do this as a class. We didn't get to do it with the current year class because of COVID-19, but hopefully you'll get to do that. All right. And when we go to part 2, I'll turn off my little cow thing and I'll show you that skull a little better. Okay, so anyway, hypsodont teeth grow continuously. You and I have what are called brachydont teeth. They don't grow continuously, right? The cow has some teeth that are brachydont, but make sure I'm not crazy here, right? In the cow, the incisors do not grow continuously. You and me, the dog, right? Nothing grows continuously. We want to be able to describe the surfaces of teeth. And if you go to the dentist, listen, you'll actually hear your dentist and the staff using these terms. So if we look at your own mouth, okay, the teeth that we have that are facing the lips, that's called the labial surface. The inside part, that's more sort of, at least on the upper teeth that are facing the hard palate, those are called that's the palatal surface. I think we even use that for the lower teeth, actually. If they're up against the cheek, we call them, that's the buccal surface. And if it's up facing the tongue, that's the lingual surface. And we use this when we're trying to when we're working on teeth and there's a lesion and you know, we want to be able to describe where the problem was. If it was a slab fracture, for example, was it, you know, was it the buccal surface? Was it the lingual surface? Things like that. And these colors do a pretty good job. So you can see the green, that's showing you that it's facing the tongue. And then these blue ones here are facing the cheek. And they identified which tooth it is, but that's not so important. You'll also be learning about what are called dental formulas. And these are really helpful. We had a dog here today named Johan, who is missing a tooth. And if I, you know, didn't know the dental formula, I might not have noticed that. So whenever I look in a mouth, I try in my mind to see if there's any missing teeth. In his case, it's a tooth that's never erupted. It never erupted, so it could cause problems later. But the dental formulas you'll see look like this. There's this I and the C and the PM and the M. So what do you think they stand for? I and C. Well, of course, I stands for incisors, C for canine, PM stands for premolar, and M stands for molar. And then what do you think these numbers mean? Well, you can probably guess. They stand for that. They're really kind of referring to. It's a little misleading because they're talking about quadrants, but it's referring to the upper and lower teeth. So on one side, I don't know if you can see. Here's a little dog skull. So he's got, you know, 3 incisors and 3 incisors on top. And he's got, that doesn't work very well. And he's got 3 incisors and 3 incisors on the bottom. And that's what those numbers represent. Again, for each quadrant, right? You have an upper quadrant, upper right, upper left, lower right, lower left. So just saying he's got, in each quadrant, there's 3 on the upper, 3 on the lower. He's got 1 canine and 1 canine, 4 premolars, right? That's all. In a sheep, right? It's 0, right? Sheep have that dental pad, so it's 0 on the top. They have no canines at all, and then they've got, you know, they're going to have on each side 3 premolars and 3 molars. 1, 2, 3, 4, 5, 6. And so it's helpful to have that memorized. The book says nothing about tongues, which is too bad because tongues are just amazing, right? The weird little cat tongue. Cows have crazy tongues. There's this crazy tongue. And don't snakes, don't they like sense, like they taste things with their tongue, or they can sense sound, or I don't know, right? So, you know, we do see tongue problems. We get cancers of the tongue. We get animals that they get in a fight and they lacerate their own tongue. Tongues are kind of weird to do surgery on, but the nice thing about tongues is they do heal pretty well. They have a certain amount of ability to regenerate. So if you cut off a piece of tongue, it can grow back fairly well. You know, if you cut off a piece of the kidney, it's not going to grow back. And the tongue is moist. It helps moisten food. It helps to mix food together. It's important, right? It helps you swallow. I think it's pretty cool. Okay, salivary glands are also important, and the book does say a little bit about salivary glands. Of course, they moisten your food. It'd be pretty horrible if you couldn't do that. All of us have very similar, if not identical, salivary glands. You've got multiple glands. You've got a parotid gland, a zygomatic gland, the mandibular gland, the sublingual. I think in most species, the parotid is the biggest. And so what's in saliva? It's more than just water. It's got a lot of bicarbonate. So bicarbonate is alkaline. That's important. It helps to, you know, it's kind of a natural antacid, right? It's a natural antacid. It helps keep your stomach acid from becoming maybe too acidic. And there are also some enzymes that help to digest food. Different species have different enzymes. I guess dogs and cats don't have certain enzymes and other animals do. Like there's an enzyme called amylase, and amylase it helps to digest carbohydrates. So in certain animals, maybe rats, I'm not sure, they start the process of digesting carbohydrates in their mouth. That's pretty cool. The cow is the queen of saliva. She makes so much saliva, and it's really important because I showed you that slide earlier about rumen acidosis. So the rumen is not really the stomach. The rumen is very amazing, but it is not, there's no stomach acid in the rumen. The rumen does not like acid. It likes to be a little bit alkaline, and it's all her saliva helps to keep it alkaline. So anything that affects a cow's ability to produce saliva, that can affect the health of her rumen. And we see problems. We see the salivary glands can get infected. Sometimes they get impacted. In this case, a condition called a salivary mucocele. There can be a damage, and now the saliva has leaked out and has kind of accumulated in the fluid, in the tissues around the gland. So there's a lot of different problems we can see. Okay, so we're going to leave the mouth and go to the esophagus. And you can kind of see food traveling down this human's esophagus. Again, a lot of smooth muscle. Well, I shouldn't say a lot. There is smooth muscle, and once everything is under conscious control, so it's all skeletal muscle up here. The moment you get the food to the back of the throat, there's no more skeletal muscle. It's all smooth muscle, and that's what's going to carry it down to your stomach here. The esophagus can develop problems of its own. There's a condition called megaesophagus. The esophagus, I'll show you here. The esophagus is supposed to be this really narrow tube. On an x-ray, you can't even see it on a normal x-ray. So here you're looking at a dog line. This is a dog in lateral recumbency. This is an x-ray of the thorax. And you see this right here? This is the esophagus, right? It is not supposed to look, it's not supposed to be all stretched out like that, right? Can you see that? And here it is, all stretched out. There's the stomach, right? That's the normal stomach, but here's this esophagus. And this condition can happen. There's different reasons why it can happen. One reason is this immune-mediated condition where the body is attacking acetylcholine receptors that you've learned about. And so the smooth muscle just can't function, and it just gets all floppy and stretched out. And what happens is these poor dogs, everything they eat just sits there, and then it just comes out as all this undigested food, and they call that regurgitation. And one of the solutions is we create what's called a Bailey chair. They sit in this chair, and that gravity will help the food enter the stomach. So, and here they've applied what's called contrast. It's a kind of a liquid called barium that lights up when you take a radiograph, and they're using that to just confirm. Sometimes you can't see the enlarged esophagus, so we can use barium for all sorts of things. But here, the barium is what's making it all white. It's just a special liquid. We can use it for all sorts of gastrointestinal problems. It can help us to diagnose gastrointestinal problems on radiographs. And so, in fact, here you can see it. it's entering this cow's stomach, and we'll actually use that barium next year. Okay, as we approach the stomach, the esophagus there's some muscles there, what are called the cardiac sphincter. It has nothing to do with the heart. So it's this word cardia has nothing to do with the heart. But this sphincter in you and me and cows, it's not a very strong sphincter. Well, I mean, what I should say is, it's strong, but it's fairly easy for us to vomit. It'll open up and let us vomit. It'll let the cow, regurgitate its cud so it can keep chewing. Oh, I'm sorry. Okay, I'm forgetting. We're talking here about why horses cannot vomit. So in horses, there's a few reasons why they can't vomit. So one is, I'm sorry, in people and horses, and oh my gosh, this is the problem of doing these things. I can't edit anything. Okay. All right. In you and me, those cardiac muscles are not that strong. All right. Where the esophagus enters the stomach. In the horse, they're very strong. The angle that the esophagus comes into the stomach is really steep, and food doesn't stay very long in the horse. But the main reason are these really strong cardiac muscles around the sphincter. What that means is that a horse can't vomit, and vomiting is important. If you think of times in your own life that you needed to vomit, and now imagine what if it was physically impossible for you to vomit. There are some cases where if a horse could vomit, they wouldn't develop other problems. So let's say a horse has a bunch of fluid, let's say the horse has colic and he's got, fluid or gas building up in his stomach. It would be nice if he could just vomit. It would relieve the problem, but he can't. The liquid is just trapped there. And rabbits have some of the same qualities that prevent them from vomiting. So in the stomach itself, the stomach is pretty amazing, right? You're walking around with this sac that has a pH of 2. And as your book says, that would like destroy metal. I mean, that's a very acidic pH. And yet it doesn't hurt you. You're walking around with this, hydrochloric acid, and it doesn't hurt you. Microbes can't survive, but you can. So why? Why does the stomach not digest itself? Sometimes it does, and that's what causes those ulcers, but usually it does not. And you might find this kind of interesting. There's animals like buzzards and vultures, right, that eat rotten food. They eat carrion. Why are they able to do that? If you and I ate it, we would get sick. So how is a buzzard able to eat, rotten roadkill? Well, their pH is even more acidic. So that's kind of cool, I think. And anyway, we're also going to learn how the stomach and the intestines work together. How do they coordinate their actions? How does the stomach produce, stomach acid when it needs to? So we'll talk about that. And the stomach is made up of several parts. It's kind of this C-shaped organ. I'm not going to talk a lot about the anatomy, but we have these. It can expand in size. This part called the fundus and the body. Food's going to come in here, right? And it can get mixed around. Your stomach will churn and produce various liquids. And then little by little, not all at once, but little by little, this liquid, it's called chyme, gets produced. It's kind of the, it's what's going to get digested. Chyme, I can't, something like that, chyme. And so let's look at the actual parts of the cell. So we're zooming in on the, this would be like the mucosa and the submucosa. So here we are, here's the stomach itself. I'm just gonna draw the rest of the stomach. There's the stomach, and there's stomach, acid, and I don't know, there's some M&Ms that you ate earlier, and here's a banana. Okay, anyway, you get the idea. So there's several cells we're going to look at here. There are parietal cells. They're actually making the hydrochloric acid. There are these things called chief cells making something called pepsinogen. We'll talk about that. These goblet cells are also known as mucus neck cells. That's not how you spell it. Okay, it's spelled M-U-C-O-U-S. They make mucus, which is spelled M-U-C-U-S. And then these cells way at the bottom of these little parts of this little kind of gland here, they make what's called, they're G cells, and they make what's called gastrin. So let's look at each of these. And yes, that's right. Altogether, they're helping you digest that snack. All right. So hydrochloric acid, what does that do? It's actually going to change the shape of proteins. It's not going to break them up into little pieces, but if you ate some sort of a protein, peanut butter, a hamburger, whatever, it's going to start to change the shape, kind of unfold it. We call that to denature the protein. And the other thing hydrochloric acid does is it's going to activate pepsin, and I'll talk about, well, it's going to activate pepsinogen into pepsin. So let's talk about that next. These chief cells make pepsinogen. And whenever you hear the word ogen, it means it's an enzyme that's in an inactive state. I think those are also called zymogens. But anyway, so you remember you learned about angiotensin and angiotensin converting enzyme. Well, angiotensin starts out as angiotensinogen, but I think it's renin that activates it. Well, here it's hydrochloric acid that activates pepsinogen into this enzyme called pepsin. And it'll activate it up here, right? It does not activate it down here. Right, so this guy's making hydrochloric acid, and that goes up there, and then the chief cells, oops, here's the chief cell making pepsinogen, and the pepsinogen is going to get activated up here. I don't know what I'm trying to draw. Okay, I'm just trying to draw something exciting. Okay, not working. So hydrochloric acid will denature a protein, but pepsin is proteolytic, and lytic means to destroy. What the pepsin will do is it will start to chop protein up into smaller pieces. Not completely. It's not going to break them down to amino acids, but it is going to start, to chop them up. So again, hydrochloric acid's making the protein unfold, and then pepsin is chopping it up. And you can see it in action here. In this little experiment, they put a little hunk of meat into 3 test tubes. And you can see if it's just hydrochloric acid or just pepsin, it doesn't totally digest the meat, but you put them together and what a team. It destroys not destroys, but it's breaking that protein down into smaller peptides. And again, it's not 3 effects, it's only, I think, 2 effects. So again, one effect is it's going to activate pepsin, and then the other is it's going to denature the protein. These glands that we find in the stomach, we have these things called goblet cells. They actually look like little goblets if you look at them under a microscope. They're also called mucus neck cells. I gotta just cross that out. That really annoys me. Again, mucus with an O is an adjective, like mucous membranes would be spelled like this, right? But mucus is what my nose makes and my goblet cells make. That's mucus, M-U-C-U-S. And we'll talk about mucus more, but that's what's really protecting the stomach, right? You've got this acid, but below the acid is this constant layer of mucus that that the hydrochloric acid will kind of destroy, but then the goblet cells just keep making more mucus. So it's a very protective little guy. And then finally, these G cells make this stuff called gastrin, which is a hormone. It's kind of a weird hormone because it's made by the stomach. It goes into the bloodstream and only activates the stomach. Well, the stomach and the small intestine. So it's kind of an odd local hormone that travels through the blood, but it doesn't affect your brain. As I don't think it affects your brain. It doesn't affect your fingers or your eyes or your heart. It just affects the stomach and small intestine. So what does it do? You've heard of histamine and antihistamine. There's histamine receptors in your lungs and your nose, and that's what, when you have allergies, they cause all that redness and swelling and irritation. Well, there's a different kind of histamine. Well, it's a different kind of histamine receptor that we have on. It's on kind of the blood side of your of these cells here, of the parietal cell. And what they do is when gastrin will come along and stimulate the parietal cell, these histamine receptors, and that will tell the parietal cells to make more hydrochloric acid. So when you've just eaten, you're making a lot of, you'll start to make gastrin. You'll start to make, that will tell your parietal cells to make more hydrochloric acid to help you digest that food. And the gastrin will also get the muscles of the stomach to start contracting. And a little sneak preview, drugs like Prilosec and Pepcid, they actually, they prevent heartburn by moderating or modulating some of the things that we just talked about. And we'll talk about Prilosec and Pepcid next week in pharmacology. Okay, so we'll talk a little more about mucus and the goblet cells, and we'll talk about it in this lens of ulcers. So why does stress and certain anti-inflammatory drugs, why do they cause stomach ulcers? Well, it has to do with your old friends, the homeostatic prostaglandins. So I've made this a little bit wordy. Again, these goblet cells are making mucus, a very protective little gelatinous goop. And there are these good prostaglandins, right? The homeostatic prostaglandins. That little plus means to stimulate, and the little minus means to inhibit. So they will stimulate the goblet cells to make mucus, and they'll actually inhibit parietal cells from making hydrochloric acid, just trying to keep everything in balance. Well, things like cortisol, the stress hormone, NSAIDs, especially the older ones like aspirin and phenylbutazone and flunixin, and any glucocorticoid that's been prescribed like prednisone. Well, their job is to block the bad. Well, yeah, their job is to. And I shouldn't. It's not stress's job, but for NSAIDs and glucocorticoids, their job is to block the bad prostaglandins. But they end up blocking some of the good prostaglandins too. And of course, cortisol is a glucocorticoid, so it does the same thing. It's blocking this little production of this little guy, right? So you're not going to have the mucus, and now there's nothing to stop that stomach acid, right? So here's all this mucus. Watch what happens. Uh-oh, nothing is going to prevent your stomach from starting to just digest away at the mucosa and submucosa. And certain species are more prone to ulcers than others. Horses, in particular, are prone to ulcers, although we see them in dogs and cats. But horses and actually pigs are kind of prone to them. And here's the reason why. You and me, your entire stomach has those glands that make, they make everything, but they make mucus in particular. Horses are not like that. They actually have a whole part of their stomach that has no glands. It's this non-glandular part. And then they have another part that is glandular. Isn't that weird? One whole part of their stomach does not make glands. And you can see that here. We're inside a horse's stomach. And here's the part that makes glands. This part does not. So this part is never going to have mucus. Well, it's never going to make mucus. And I'm going to say, for the sake of illustration, that it doesn't have that coating of mucus on it. Now that's okay. Food travels through the horse very quickly. We'll assume it stays in this part of the stomach. This is this line. It's called the margo plicatus. I don't know how to say it, but anyway, that's just where the glandular stomach and the non-glandular stomach border each other. And again, a normal horse, right here we are. This is the glandular part, right? This up here is the non-glandular part. I'm just going to kind of do that, right? That's the non-glandular part. So this is the part that has ulcers in this horse. Again, most horses, food travels through very quickly. It stays in the glandular portion. Stomach acid is not going to burn anything, but this is why we do see ulcers a little more commonly in horses. And pigs are a little different, but we don't need to talk about that. It's interesting if you want to look it up, but we don't need to talk about that. Okay, so that's part one, and there's a little Kahoot you can check right now. Just kind of check your understanding. Again, it's very basic. There might be. I made this last year. There might be several Kahoots about the digestive system. So look for one that's for the upper digestive system. Well, let me play around with that. Anyways, that's part one. And I'll see you in a little bit in part two.